Scientists just announced a terrifying structure of advanced alien in space. Dimming stars are nothing new to astronomy. In fact, it's one of the main ways we detect exoplanets when they pass between us and the star, dimming the star's light fractionally by less than 1% usually. But although KIC 8462852 itself seems to be a pretty normal yellow-white dwarf, its dimming behavior is weird. Real weird. NASA's Kepler telescope first noticed the mysterious KIC 8462852 dipping in brightness at seemingly random intervals between 2011 and 2013. Kepler, which was launched to observe the stellar dimmings caused by an exoplanet passing in front of its star, discovered that Tabby's star dimming was much more erratic than a typical planetary transit. It was also more extreme, with brightness dropping by up to 20% at times. This was the passage of something much larger and more irregular than a small circular planet. The team that made this discovery, led by Yale astronomer Tabitha Boyajian, the star's namesake, suggested several explanations for its strange behavior, including the star itself being variable, being surrounded by clouds of dust or dusty comets, or planets colliding or still forming around it. However, KIC 8462852 made headlines when Wright and colleagues proposed that the star be used to search for evidence of a large manufactured structure built by alien life. Further research revealed that the infrared glow expected from a large object orbiting close to its star did not exist. They did not, however, confirm or refute any other explanations. During the dimming, astronomers had to closely observe the star and take spectra. They had to wait for that. Boyajian and her team have been keeping an eye on KIC 8462852 with the help of a network of amateur star watchers, and more recently with the privately run Las Cumbres Observatory, a network of 18 robotic telescopes at 6 locations around the world. The first indication of the star's recent dimming came from Tennessee State University's Fairborn Observatory in southern Arizona on April the 24th. However, it wasn't until late last week that astronomers were certain it had entered a new dip. On the 19th and 20th of May, it was 3% dimmer than usual. It looks like the dip has mostly ended, Kipling said, but in the Kepler data, we saw an episode of multiple dips clustered together over the span of a few weeks. The dimming progression also bears a passing resemblance to some detected by Kepler, lending credence to the theory that the same object is repeatedly passing in front of the star. Newly analyzed observations from NASA's planet-hunting Kepler Space Telescope shows that the star KIC 8462852, whose occasional dramatic dips in brightness continue to perplex astronomers, has also dimmed overall in recent years. The steady brightness change in KIC 8462852 is pretty astounding, study-led author Ben Monet of the California Institute of Technology in Pasadena said in a statement, because these brightness dips are too large to be caused by an orbiting planet, scientists begin to propose alternative explanations. Perhaps a planet or family of orbiting comets collided, resulting in a cloud of dust and fragments that periodically obscured the star's light. Perhaps the dimming is caused by an unknown object in the deep space between the star and Earth. The brightness dips are even consistent with an intelligent civilization building a massive energy-collecting structure, though researchers have been quick to point out that this alien megastructure scenario is highly unlikely. From 2009 to 2013, Kepler observed KIC 8462852 and approximately 150,000 other stars. Monet and Simon discovered that KIC 8462852 became nearly 1% darker during the first 3 years of that time period. The brightness of the star dropped by a startling 2% over the next 6 months, then remained constant for the remaining 6 months of the observation period. Kepler has since moved on to a new mission known as K2, during which the telescope searches for exoplanets on a more limited scale and conducts a variety of other observations. This star was already completely unique because of its sporadic dimming episodes, Simon said in the same statement, but now we see it has other features that are just as strange, both slowly dimming for almost 3 years and suddenly getting fainter much more rapidly. It's a big challenge to come up with a good explanation for a star doing three different things that have never been seen before, Monet said, but these observations will provide an important clue to solving the mystery of KIC 8462852. The first investigation into the mysterious signals were led by Tabby, who was then at Yale University and is now at Louisiana State University. The star was named Tabby's star in honor of her. She started at the same time that a continuous monitoring program was required to keep an eye on the star for more dips. Today's new analysis is the result of that program. It was funded by a Kickstarter campaign that received over 1,700 backers and raised more than $100,000. The astronomers monitored the star from March 2016 to December 2017 in collaboration with the Las Cumbres Observatory, a privately funded organization that operates 21 telescopes at 8 locations around the world. They recorded 4 more dips during that time, though none were as dramatic as the originals, reaching only a % or 2. The Kickstarter backers named them Elsie and Celeste, Skara Brae, and Angor. The dimming events were captured by multiple wavelengths, which was important for the analysis. If an alien megastructure had caused the drop in light, it would have blocked all wavelengths in the same way at the same time. Instead, different light wavelengths dropped by varying amounts. This is exactly what would be expected from starlight passing through a hazy dust cloud. This occurs because dust grains scatter light based on their wavelength. Blue light, which has shorter wavelengths, is more easily scattered than red light, which has longer wavelengths. This is why our sky is blue. The molecules in the air have scattered the direct light of the sun. The new observation of Tabby's star show that it dims more at blue wavelengths than at red wavelengths. As a result, its light passes through a dust cloud rather than being blocked by an alien megastructure in orbit around the star. The results of the new analysis of KIC 8462852 were published in the Astrophysical Journal Letters. It backs up the findings reached by Hoon Ming of the University of Arizona Tucson and colleagues in October of 2017. They used NASA's Spitzer and Swift missions and the Belgian Astrolab IRIS observatory to observe the star at multiple wavelengths. The Astrophysical Journal published these findings. While it's not aliens this time, the story serves as a valuable reminder that unexpected signals of this nature should always be avoided. Something unexplainable in an unexpected observation, rather than a deliberate radio message to us, is most likely how we will detect the presence of extraterrestrials, assuming they exist in the first place. These days, a new sky survey has revealed a variety of stars that exhibit similar dimming behavior, 15 stars that appear to be very similar to KIC 8462852, and another 6 that appear to be even more extreme. Finding more stars that behave in the same way could provide additional clues. For example, if they're all the same type of star, or if they're all in the same kind of environment, that could tell us something. With this in mind, University of Nebraska-Lincoln astronomer and physicist Edward Schmidt set out to find out. He combed Northern Sky Variable Survey data collected between April of 1999 and March of 2000 to find candidate stars with irregular variability, excluding all stars with explainable dimmings, such as those consistent with eclipsing binaries. They resulted in 21 stars. He obtained light curve data for these 21 stars from the All-Sky Automated Survey for Supernova. This was compared to the light curve of KIC 8462852, and there were some intriguing parallels. This randomness is significant because KIC 8462852 isn't the only oddly dimming star out there. Epic 204376071 was seen dimming to a depth of 80% earlier this year in a single solid opaque event, as if an abnormally large ringed planet had passed in front of it. Epic 249706694 has light dips that are erratically timed, but they are all similar in depth. Schmidt's stars are significantly closer to KIC 8462852. He classified them into 2 groups. In terms of timing, the slow dippers, of which 15 were identified, were the most similar to KIC 8462852. However, 6 rapid dippers made similar dips but much more frequently. This difference is unknown, but it does suggest that the dimming behavior has a range of characteristics and that the phenomenon that causes it has a range into which KIC 8462852 could fall. That brings us to the end of today's video. If you liked the video, please leave a like and comment below. Also, if you're new to this channel, subscribe and click the notification bell to get notified when we upload more content.